Hello student, you are welcome here in the third part of the current electricity video. Here I will show you about the concept of resistance. Okay. We will discuss the factors that causes the resistance of a conductor, and finally we will give the details explanations of those factors, how they put the obstruction to the flow of current. Okay, and after completing this video you will have better idea about the resistance. I'm not going to make a very big story of the resistance, but mind me students, it is important to understand the concept of resistance, otherwise you will face the problem while reading the current electricity chapter, right? First of all, I am going to show what is resistance, right? Resistance is the opposition to the flow of current. This is the dictionary meaning of resistance. Okay, so in more theoretical way we can say the resistance is a property of a conductor which put an obstruction to the flow of current, right? Unit of resistance is ohm. Okay, we also represent ohms by this symbol, right? And the pictorial representation of a resistance is like this. Okay, and we designate the resistance generally by the letter capital R or sometime with small r. Okay, this is fixed resistor. Okay, what we call it, fixed resistor. Okay, and we also represent a variable resistor with this symbol. Okay, this is variable resistor. I am telling resistor because resistor is a noun. Okay, and resistance is a property of this resistor. Okay, I am showing here a conductor quite thicker than the normal whatever we see in our daily life. When this conductor is not connected with any source, then we know there are free electrons inside a conductor, but these free electrons moves in zigzag direction. Okay, there are also holes, that means positive ions. What are positive ions? Positive ions are those particles which have lost electrons. Okay, the electrons moves inside the conductor in zigzag way. Okay, that means there is no any movement of the electron in a particular fashion. Okay, but when we connect a voltage source across this conductor, then these electrons try to flow towards the positive terminals of the voltage source. Okay, so what happens? I am showing here the another picture in which we have applied a potential difference. These are the positive ions. Okay, right, these are the positive ion. At the negative terminals there are more number of the free electrons, right? And at the positive terminals there are less electrons. Okay, and due to this positive potential connected at this terminal, these electrons flow towards positive terminal. Okay, I am showing only few electrons here, but during the process of traveling from this left end terminal to the right end terminals, these electrons collides with the positive ions. Okay, so its speed decreases. Again they try to attain the acceleration to travel to the opposite positive end, but after few time again it collides with the another positive ions, and this process repeats. Due to this collision there remains few electrons which drifts, that means which do not become successful to reach to the positive terminal, right? And that is the because of this collision, and that is the resistance which are decreasing the electrons fully reach from left side to right side to the positive terminal. Okay, if there would not be this material, or if there would be very good conductor than this material, then the more number of electrons would become successful to travel from negative to positive terminal, right? That is because of the property of the conductor. Okay, suppose for example I am telling the electron travels through this conductor are 70. Okay, and suppose this is iron conductor, and if there would be a copper conductor instead of this iron conductor, then I can say the more electrons, suppose for example 100 electrons would become successful in traveling from left side to right side here. Okay, that means there would be less resistance if the conductor would be copper. That is the resistance. Okay, so I think the resistance are the opposition offered to the flow of electron actually, which happens inside the conductor, right? I think I am able to clarify the resistance concept. Okay, now I am going to explain the factors that affect the resistance of a conductor. Okay, the first factor which causes the resistance is the nature of the conductor, first one, or we can say the type of conductor. Okay, second one is the length of the conductor, and third one is the thickness of the conductor. Okay, or we can say area of cross section. Okay, area of cross section, or you can also say it thickness. Okay, the fourth factor is the temperature of the conductor. Okay, that means if the temperature of the conductor will be more, the resistance of the conductor will be more. Okay, now let me explain in details about this type of the factors those are causing resistance of a conductor. Okay, so first one is the type of the conductor. Okay, type of the conductor, or we can say nature of the conductor. Okay, it means if we choose different type of the conductor, like if this is a copper conductor, and suppose if this is a aluminum conductor, this is copper conductor, this is aluminum conductor, and if you are saying this is gold, okay, and this is aluminum. Okay, so the different material of the conductor, or we can say the conductor of different materials have different degree of opposition to the flow of current, or we can say have different resistance, right? So the resistance of these three conductors will be different. Okay, therefore we can say here that the resistance of copper, aluminum and golds are different. Gold is the best conductor among these three, we know this, right? And after that copper is the better conductor after gold here. So as the gold is very costly material, therefore we uses copper or aluminum conductor, right? The students sometimes ask why we use aluminum instead of copper, or sometimes why we use copper and not aluminum. So there are different types of the property of the aluminum and copper which you will study in the higher classes. Because of those factors, the aluminum and coppers are used due to those type of the property. Okay, but the use of copper are more than any type of the conductor because it is cheap, it is more flexible, its property are of very great in comparison to other materials. Okay, okay friend, this is a conductor and its length is suppose L, and if the resistance is R, then we can say resistance of the conductor is directly proportional to the length. What does it means? It means that if you increase the length, then the resistance will increase also. Okay, right? And if you decrease the length, okay, like this instead of this, the resistance will also decrease. That means resistance is directly proportional to the length of a conductor. If the current has to cover more distances, that means the current has to face more obstruction on the way, right? And if the distance is less, then the current which needs to travel from this into this end will face less obstruction than that of this conductor, because the distance to flow to cover for this conductor is more, right? The third factor that causes the resistance of a conductor are area of cross section or thickness. Area of cross section. What is the area of cross section? First let me tell this one. Suppose I am showing this a conductor. If you cut the conductor here, so you will see this type of view. Okay, this is the cross section, right? Suppose this cross section, you notice this cross section, and also you notice this cross section. So what is the difference? If this cross section is capital A and this cross section is small a, okay, that means here A is bigger than A, or we can say this conductor is thicker than this conductor, right? So if the resistance of the conductor is R, as I told earlier, then R is inversely proportional to area of cross section. Suppose area of cross section we denote by A later, okay, area of cross section, okay. That means the resistance is inversely proportional to the area of cross section. What does this means? If the area of cross section will be more, then the resistance will be less, because the divisor will more here, right? And in another sense we can say that current can pass more easily through this conductor than this conductor, right? The last one is the temperature of the conductor, okay, fourth one. That means if the temperature of the conductor will be more, then the resistance will also be more, okay. That means resistance is directly proportional to the temperature of the conductor, okay. The resistance of a conductor at temperature T can be determined with this formula, okay. RT equal to R0 into 1 plus alpha T, this equation, where alpha is the temperature coefficient of the conductor and T is the rise in temperature, okay. That means if the temperature goes by 20 degree up, that means this is the increase in temperature, okay. Or you can say T2 minus T1, this is T2 minus T1, that means final and the initial temperature difference, okay. You will read in the higher classes this equation, right? So resistance of a conductor is directly proportional to temperature. Okay students, now I will show you the calculation part of resistance, okay. A conductor has two main dimension. One is length, okay, and another is area of cross section, this one, okay. So we know that resistance is directly proportional to the length of the conductor, and resistance is also inversely proportional to area of cross section of the conductor, okay. If we combine these two equation number 1 and equation number 2, we get that R proportional to L by A, okay. or R equal to rho into L by A, where rho is a constant. It is called resistivity of the conductor. Okay. Right, and its unit is ohm meter at 20 degrees centigrade. Generally its value is given at 20 degrees centigrade, right? Why the unit of the rho is ohm meter? We can find from here. Rho, you can write rho equal to R into A by L. Okay, if we put the unit of R, that is ohm, and unit of A is meter square if we take the dimension of the conductor in meter, and unit of L is meter. Okay, so 1 meter is cancelled here and it left with ohm meter. Okay, that's why the unit of the resistivity is ohm meter. Okay, so this is the resistance equation that is determined from the dimension of the conductor. Okay, right. Now the value of resistance is also calculated from the other parameter, like if voltage V and current I is given, then resistance equal to V by I. Okay, and this is also a different equation for resistance, and if watt and I is given, the value of resistance will be W by I square. Okay, so these are the equation of the resistance, and I think you should remember these equation. The next I am telling here the combination of the resistor. You should also know this one. Okay, because a few sums will come in the examination regarding the combination of the resistance, right? So first combination is very common, series combination. Okay, when the one end of the resistance are connected to the start end of the another resistor, like this. I am connected here 3 resistors, R1, R2 and R3. Okay, and if we want to calculate the equivalent resistance of these 3 resistors, then this is called RS, and it can be calculated very simply. RS, that means equivalent resistance in series combination, will be R1 plus R2 plus R3. Very simple, you keep this in memory, right? The next combination is parallel combination. I am again showing the same 3 resistors here. Okay, now the parallel equivalent of these 3 resistor, R1, R2, R3 will be 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3, right? Also keep this in memory. And when we calculate the resistance of the parallel, we follow the mathematical rule as usual. If there are 2 resistors in parallel, as I am showing, then its equivalent will be like this. Directly you can calculate Rp equal to R1 into R2 divided by R1 plus R2. Okay, directly you can write this. How it is coming here, with the same technique it is coming. I am just doing for you. Rp equal to 1 by R1 plus 1 by R2 equal to LCM is R1 into R2. Here becomes R2 plus R1. 1 by Rp equal to this. I am inverting the above equation, and it is becoming R1 into R2 by R1 plus R2. Okay, in this way you can also calculate the equivalent resistance in parallel combination of three resistors. Okay, with the same technique, by finding the LCM of the equation and doing the same technique, right? I think the calculation parts of the resistance is clear. If you have any questions regarding the resistance, about anything of the resistance, you can ask by commenting below in the video, right?